The story of the Northern Lights starts with the sun. The sun, the big fireball that is floating in the middle of space, the Earth, and all the other planets in the solar system all revolve around at different points in space. We're all just big rocks floating in space after all, aren't we? Now, this sun is such a high energy thing. It will blast charged particles. Now, the only charged particles that exist are electrons and protons. Protons have positive charges, electrons have negative charges. Protons have a definable mass, electrons have a negligible mass, and they will be thrown out at various different points, and some of these charged particles will sort of come towards Earth and Earth's magnetic field. Now, these charged particles, they'll be in sort of bunches. These bunches are known as things such as solar winds. Now, the Earth's magnetic field protects us from these very high energy solar winds. And what will happen is this sort of mist, this quick, like high density sort of blast of charged particles will hit Earth's magnetic field. And because Earth's magnetic field, it's not going to be completely rock solid and it's not going to let anything through it. It's going to sort of squish slightly, like these charged particles are going to sort of push Earth's magnetic field and sort of strain it and squish it. And then what's going to happen is the sort of outermost magnetic field is going to sort of ping back like an elastic band over to the other side of the Earth. And then when this sort of field line, outermost field line, sort of pings back and reconnects with itself, it's then going to send the charged particles along its field line. All of Earth's field lines, they sort of go around like an onion shape. They get sort of smaller as you're close to the Earth, and then they get like bigger and bigger and bigger the further you go out. And the field lines will get stronger and stronger the closer you get to Earth, and they'll get sort of weaker and weaker the further that you go out, until eventually there's no sort of magnetism, there's no force of electromagnetism whatsoever to be found. So when this magnetic field pings back like an elastic band, it's going to send charged particles along its field line and down onto where this sort of magnetic pole eventually is. So it's going to go down to where the North Pole of Earth, the North Magnetic Pole of Earth is, and the South Magnetic Pole of Earth is, and it's going to collide with gases in the atmosphere. These charged particles, they're not going to get through to Earth. That's why we have an atmosphere, and our atmosphere is very beneficial, and it's one of the reasons that we as humans are alive. These electrons and protons will collide with atmospheric gases such as nitrogen and oxygen and stuff, and it creates this beautiful aurora of different sort of colours, and it's sort of like flashing lights and stuff, and that is known as the Northern Lights, and that is one way that it's caused. But why are the Northern Lights the colours that they are? Why is the Northern Lights like pinkish and greenish and bluish and stuff? Why is that the case? Because what happens is when electrons and protons collide with different gases in the atmosphere, it's going to release different wavelengths of light. These sort of electrons and protons as photons and stuff, they're going to collide with the bonds, and then it's going to absorb certain wavelengths of this visible light, and it's going to emit other wavelengths. And that is the wavelength that we as humans are able to see from the sort of comfort of the ground. Now, these Northern Lights can occur in the atmosphere 100 kilometers up from Earth to around 600 kilometers up from Earth. Now, the colors that define the Northern Lights are nitrogen, N2 molecules will sort of release a pink wavelength of light. And this is what forms the sort of pink tinges at the bottom of the Northern Lights, because nitrogen is really only found in the lower atmosphere. It's not found higher up like where ozone is and stuff. It's going to form the sort of bottom pink tinge of the Northern Lights, where electrons get through very far and end up colliding with these nitrogen gases in the atmosphere. Now, the greenish, sort of the main colour of the Northern Lights is actually O2 molecules. O2 molecules, OO with a double bond between them, that releases a green wavelength of light, which is sort of the majority of the Northern Lights which we see, because that's the majority component of like the gases that's able to sort of absorb these electrons and protons and emit a wavelength of light as well. That is the majority component of gas in that space. Oxygen atoms, singlet oxygen atoms, form a red colour and emit a red wavelength of light, and then you're going to have hydrogen and helium, which are going to emit blue and purple sort of wavelengths of light respectively. And that is it. That is how the Northern Lights are formed. It's all to do with the electromagnetism of Earth's sort of magnetic field, how it sort of pings back like an elastic band when the solar winds sort of strain it in a way, and then it will ping back and it will send these sort of charged particles along the field lines, and that'll be right where the poles are, and that's why that's why they're called the Northern Lights, because they only really occur at the north and sort of south poles. But there's not many inhabitants in this sort of South Pole area. So that's why it's called the Northern Lights rather than the Southern Lights, because more people, such as things like Norway, Finland and Sweden, it's visible from that area, but no one really inhabited ancient Antarctica, so there's not like any mythology about the sort of Southern Lights or anything like that. But there is like actually quite a bit of mythology about the Northern Lights. Like, it was genuinely seen as like a bit of a weird sort of symbolism. Like, you weren't allowed to sort of talk to the Northern Lights or sort of awaken the Northern Lights, or things would like come for you or whatever. So it's very weird and stuff, but that's how the Northern Lights work scientifically, and I hope you enjoyed that. I hope you now have expanded your knowledge. But with that, I recommend subscribing for more content like this, and have a good day.